Now that battery would normally be attached to this wire. This is the 50 amp fuse. And then that fuse connects to the solenoid, which the solenoid is triggered by this relay, which then connects to the ignition and therefore the starter battery and the alternator. So the house battery, which would be here, is connected through this assembly here of parts to the starter battery is connected to the house battery. And these are extra fuses for appliances. But the purpose of this is to show how much power this solenoid uses. Now I'm just going to draw 12 volts from a quick power supply, and you're going to hear the click. Now, click will show us about 0.8 amps. So we have 0.8 amps that are constantly being drawn when this is engaged. So we roughly have, well, we have more than 10 watts of power that's constantly being lost here. I think there's probably many different ways to avoid this and keep your batteries, keep the energy in your batteries for other purposes. So here's another reason why this solenoid is not wise. Lithium-ion phosphate battery has something over 13 volts, up to 13.6 volts, 13.3. In any case, it's always going to be higher, or most likely going to be higher than the 12, even 12.5 of the lead acid battery. So here we have the solenoid hooked up. This is how the starter battery and the house battery would be hooked up with the solenoid. So if we had engaged it, we'll hear the solenoid click. Okay, and we see the current with the solenoid. And then with the relay, the ignition on, now we're seeing a drain from the house battery to the lead acid battery. And we're seeing at least, well, we see more than an amp because there's actually 0.7 amps going into here. So this guy's going to get hot, burning up energy. This guy's going to lose its energy that's been stored from solar. It's going to go in to essentially marginally raising the voltage of the lead acid battery. So this will be absorption charge. This will be lost energy